Mark Gibson's Human Rights Channel. Accountant with designations CPA, MBA, CMA, ACPA, ASA, Australia. Enjoy learning!
Sige. So probability is important to management decision making because of the unpredictability of future events. Decision making under conditions of risk occurs when the probability distribution of the possible future states of nature is known. And decision making under conditions of uncertainty occurs when the probability distribution of possible future states of nature is not known and must be subjectively determined. The probability of an event varies from 0 to 1 or 0 to 100%. Zero probability, the event cannot occur. Probability of 1 or 100%, the event is certain to occur. So, okay, so we'll discuss about the basic terms used in probability. So, number one, two events are mutually exclusive if they cannot occur simultaneously. So, pag-usapan nga natin to. So, can you think of any events or event that are mutually exclusive? So, meaning, um, mutually exclusive events are things that can't happen at the same time. So, for example, you can't run backward and forwards at the same time. The events running forward and running backwards are mutually exclusive. So, another example is tossing a coin. So, in tossing a coin, you can't get both a heads and tails.
You are currently the only person in this conference.
Okay. So the joint probability of two events is the probability that both will occur. So paano naman pag there's a joint probability of two events? Say for example, let's talk about say your accounting course na lang. So yan So since management science is a major subject, so we can say that passing management science will lead you to pass the accounting course. And in such a way that in number three, conditional probability of two events is the probability that one will occur given that the other has already occurred. So passing management science subject and graduating your accounting course, no? So definitely you can't graduate from your accounting course without completing management science or management accounting. So that's another example of probability. Next, two events are independent if the occurrence of one has no effect on the probability of the other. Ano kayang good example of independent probability or events or independent events, no? Sige, tulungan niyo ako mag-isip. Ano bang pwede nating example sa independent events? Siguro hindi na rin ako lalayo. Sa accounting na lang din. So, sabihin natin na passing the board exam, that's one event. and landing a job, no? Landing a good job. So siguro well, in a way, we can say they're independent events because no, passing the board exam cannot always guarantee that you'll land the job, no? Like I said, in our previous, well, in my previous class, the environment right now is very competitive, so it's not really just passing the board exam. You have to be well equipped with something else, you know. So what if in an environment you're all CPAs, so you have to have something to be at par, no, in a very competitive environment like that. So, well, siguro as an assignment, let's think of another events, no, uh, that will demonstrate these four scenarios. So mutually exclusive, joint probability, or joint events, conditional probability, and independent. No? So, okay. Sige, let's talk about expected value. So the expected value of an action is found by multiplying the probability of each outcome by its payoff and summing the products. So let's just sum up what's probability analysis. So probability, this is the extent to which the event is likely to occur. And we use probability analysis mostly in budgeting, planning, and decision making. And again, the expected value of an action is found by multiplying the probability of each outcome by the payoff and summing the products. And to understand those concepts better, let's do some discussion problems. So let's apply it to a problem. So exercise number 1 on probability. So let me just open my Excel file so we can solve this together. So so the requirement is to prepare a cost comparison study of the two machines. Now, let me read the problem. So the owner of Barako Coffee Shop must decide between the acquisition of two types of coffee brewing machines, brewer A and brewer B. Acquisition costs of the two brewers are the same. Brewer A requires a monthly fixed operating costs of 20,000 pesos, while Brewer B requires 25,000 pesos. Selling price per cup of coffee would be the same regardless of which brewing machine is used. The variable production cost per cup of coffee is 0.9 pesos if Brewer A is used and 0.60 if Brewer B is used. Monthly demand varies between 50,000 and 80,000 cups according to the following probabilities. So here's the probability table, no? So we have demand. So sabi, at 50,000, there's a probability or there's a chance that it will occur for 10%, 54,000 for 20%, 65,000 at 40%, 75,000 at 22%, 80,000 at 8%. No? So, well, in this type of problems where demand is provided, all we need to do is we'll multiply the two to get the expected value of monthly demand. No? So, paano yan? Let's go to the calculation. Lakihan ko ng konti para okay. So ito yung, well, ginawa ko na naman is kinuha ko yung given. So we have 54, 50, 54, 65, 75, and 80,000. So I just multiply it with the probability. So remember class, in probability, the table, I mean the given should always be at 100%. So in this case, the total of the 5 demands is 100%. So we get the product of the two. So 50,000 multiplied by 10%, that's 5,000. 54 multiplied by 20%, so that's 10,800. 65,000 multiplied by 40%, so that's 26,000. 75,000 multiplied by 22%, so that's 16,500. 80,000 multiplied by 8%, so that's 6,400. So we get the sum, so that's 64,700. Now, 64,700, this is the expected value of monthly demand. All right. Now, the requirement, remember, in exercise 1 is to do a cost comparison. Now, in doing cost comparison, and it's also provided here that the selling price per cup of coffee would be the same regardless of which brewing machine is used. So therefore, whether the selling price is given or not, in this case, it's not given, since they are the same for whether brewer A or brewer B is used. So what do we call this information here? This is irrelevant, no? Kasi nga, this is irrelevant in such a case that they're the same for uh, two options, no? So either brewer A or brewer B, it will give us the same selling price. No? So therefore, we'll proceed out, we'll use variable cost and the fixed cost to do cost comparison. No? So okay, so let's do brewer A. Okay, brewer A, sabi, the problem states that the cost per cup would be 0.9 and it's 0.6 if brewer B. No? So variable cost natin is 0.9 for brewer A and 0.6 for brewer B. Multiply, of course, by the number of demands. No? So yun yung na-calculate natin kanina. So 64,700 multiplied by 0.9, so that's 58,230. Okay, brewer B naman, ganun na lang, no? Ituloy na natin. Brewer B, so that's 64,700 multiplied by 0.60. So that's 38,820. Fixed cost, ayun, given. So require a brewer A requires monthly fixed operating cost of 20,000. Okay. While brewer B requires 25,000. So this should be 25,000. So we get the total cost. So total for brewer A is 78,230. And for brewer B is 63,820. So now, of course, diba, sabi natin probability analysis is used in decision making. Now, we're presented with two machines. Given the probability of demands, so which one should we choose? Is it brewer A or brewer B? So the answer is brewer B because it will only have it will generate a total cost of 63,820 compared to the 78,230 in brewer A. Okay, so that's the answer to exercise number 1. Actually, the requirement is to do a cost comparison. So, of course, in problems like this, we're actually being asked to decide which one to acquire, no? So brewer A or brewer B. So the answer is brewer B, as it will generate lower cost compared to brewer A. All right? Sige. Let's do another exercise on probability. So the requirements are, number one, the probability that a customer will select model C. And number two, in running a simulation of the computer demand, the following numbers are drawn in sequence. Number 2, 1, and 8. The simulation indicates that the third customer will purchase which model. Okay, so let me read the problem. A computer store sells 4 computer models designated as P104, X104, A104, and S104. The store manager has made random number assignments to represent customer choices based on past sales data. The assignments are shown below. So you have model A, B, and C, B, C, and D, and then random numbers. No? This is the assigned numbers. No? So from 0 to 2, that's for A, 3 to 6 for B, and 7 to 8 for C, and 9 for D. Okay, so let's solve problem number 2. So when you're presented with data like this, all you have to do is count the number, no? So number of in this case, no, for model A, how many random numbers are assigned for model A? So let's count. So 0, 1, and 2. So the answer is 3. 0, 1, and 2. For model B, that's 3 to 6. So 3, 4, 5, and 6. So there are 4 numbers assigned to model B. For model C, 7 and 8. So you have 2 numbers assigned to model C. And for model D, there's only 1 number assigned to it, which is number 9. So in total, still 10. Now, we get the weight, no? So in getting the weight, so it's just simply getting I mean, just have to get the weight, no? So that's 3 over 10, so that's 30%. 4 over 10, so 40%. And for C, 2 over 10, 20%. And finally, for model D, that's 1 over 10 or 10%. Now, actually, the question number 1, what's the probability that the customer will select model C? So the probability is 20%. So there's a 20% chance that the customer will select model C. Okay, so that's the answer to requirement number 1. Now let's go to requirement number 2. So in running a simulation of the computer demand, the following numbers are drawn in sequence. So you have 2, 1, and 8. The simulation indicates that the third customer will purchase, saan ba yung 8? So 8 is a random number assigned to model C. Okay, so the answer is model C. Okay, what if the question is for number 2? So the answer is model A. Okay, so that's how easy this problem, no, how to deal. Okay, so that's exercise number 2. Okay, so wala hindi ka pa na-challenge, no? So that's how easy probability is. Actually, probability and decision tree, these are, let's say, the most basic quantitative methods, no? Because next week we'll be dealing with the linear programming. So I think that's well, at least during my time in the undergrad, no, that's the most challenging quantitative techniques, no? Because the rest would be just following through the instruction. So like Gantt chart, it's just used for scheduling and for planning your activities. So that would be on our 6th week. So we'll after this session we'll have 2 more weeks. So in fact, next week will be your midterms week already. So that's how fast and our discussions. Okay, so let's do exercise number 3. So what is the best estimate of the expected sales of the new product? So the probabilities shown in the table represent the estimate of sales for a new product. So we have sales in units and the probability. So if sales in units 0 to 100, so there's probability of 10%, 101 to 200, 30%, 201 to 300, 40%, 301 to 400, 20%. Okay, so let's do exercise number 3. So class, when you're given a range like this, so all you have to do is get the midpoint, no? Because you don't want to multiply everything else with the probability, so that's not how to go about this type of problem. Again, when you're given a range as an event, so all you need to do is get the midpoint, no? So 0 to 100, midpoint is 50. 101 to 200, that's 150. 201 to 300, so that's 250. Saan nakakasunod, class, ha? 301 to 400, the midpoint would be 350. So you just need to multiply that with the probability given naman. So that's 100% in total. So 50 multiplied by 10%, so that's 5. 150 multiplied by 30%, that's 45. 250 multiplied by 40%, so that's 100. 350 multiplied by 20%, so that's 70. So we get the sum, so that's 220. Okay, so this is the best estimate of the expected sales of our new product. No? So that's 200. Well, the key thing is if you're presented with a range instead of an individual value, so all you need to do is get the midpoint before you multiply it with the probability to get the expected values. All right? Okay. Okay, so next, exercise number 4. The requirement is the probability that there will be a 10% increase in the cost of both material 1 and material 2 is. So a company uses 2 major material inputs in its production. To prepare its manufacturing operations budget, the company has to project the cost changes of these material inputs. The cost changes are independent of one another. The purchasing department provides the following probabilities associated with projected cost changes. So here are the events, no? Cost change, 3%, 5%, and 10% increase respectively. Now for material 1, it's 0.5. Material 2 is 0.1 for a 3% increase. 0.2 for material 1 and 0.4 for material 2 for a 5% increase. And finally, it's 0.3 for material 1 and 0.5 for material 2 for a 10% increase. It looks tricky, but class, you'll be surprised that you only have to multiply these two, 0.3 multiplied by 0.5. So that's 15%. No? So in this case, we have joint probability. Joint probability of occurrence of 2 independent events. So product of their individual probabilities. Okay. So since we have 2 materials, in our production. It mentioned here that a 10% increase will actually result to a 0.3 for material 1 and 0.5 for material 2. So therefore, to get the probability, a 10% increase, so we have to multiply 0.3 by 0.5. No? So that's equivalent to 15%. Now, what if we're being asked about the probability that there will be 3% decrease in the cost of both material 1 and material 2? Okay, so the answer would be 0%. Why? Because the question was a 3% decrease. But remember, there's no event here that actually mentioned about a decrease, no? So it's all an increase, no? So therefore, just be careful in reading the requirement, no? So that's always my tip to you, no? So before going through the problem itself, so you just have to read the requirement first. Okay, so this is really a basic problem in terms of joint probability. Okay, sige. Okay, so let's continue our discussion. Actually, that ends my discussion on probability analysis.
This has been your instructor, Mark Gibson. Thank you for learning with us. See you in our next discussion. Don't forget to like and subscribe. See ya!